So let's unhide the Bezier curve, which we have hidden in the previous part. Now hide the connector, and let's go to geometry nodes. Okay, so let's go to modifiers. Let's select actually the Bezier curve and go back to our geometry node setup. So to add an object that we have modeled from the scene, we will add a object info, which will come with the outputs of geometry, which is what we need. So let's select actually the connector. Okay, now obviously the connector was modeled with 1 meter scale, or meters scale, so we will need to scale it down to fit to our flat cable. So let's search for transform, and we will do it in the same way like we did it with the copper ends. So let's actually copy the group input, Control C, Control V, or add search group input. It doesn't matter in which way you do it. Okay, so let's separate the connectors a little bit from the other part of the node setup. Okay, so we will use the strand diameter as a basis for the scaling of the connector. So let's actually feed the geometry into the transform node, and let's add our viewer node. Okay, so let's plug it like here, like this, and let's unhide. Obviously the connector is gigantic, so let's add the combine XYZ, and let's see what happens if we plug in the strand diameter directly into the X and Y coordinates. So let's see what happens. Okay, that's not what we want. Let's actually, just a second until I center it. Okay, that's not what we want. Let's plug it into the X and see. Okay, we have 0 on the Y. If we change it to 0.01, we have the connector scaled pretty much, I think, in the dimensions that we need. So we just need to change the. We can keep the strand diameter as the basis for the X and Z scale, and we just need to multiply the strand diameter by some coefficient and feed it into the y-axis. So let's search for a math node. Okay, let's plug the strand diameter set to multiply, and we will use some number of 5 for the value for the coefficient of the strand diameter multiplier. Okay, so let's put it into here. Let's change it to 4 or 3. I think that's good enough. Maybe 2. Okay, 2 looks good to me. Okay, so here we are. Let's delete the viewer, and actually what we will do is pretty much the same as what we did with the uninsulated copper ends. That's placing instances on points. Yeah, so let's copy it. Also copy the align Euler to vector and curve tangent, because we will need it. And we will do it in the same way as we did it with the uninsulated copper ends. We will have two individual instances on points for one end, and for the other one that will be translated on the x-axis by opposite directions. So let's also copy the endpoint selection, move it to here. Let's plug the selection. Okay, align Euler to vector, and let's also get the source of points, which is this curve. Okay, and plug it to points. And let's take this geometry and see how it will be actually placed. Okay, and we need to feed the output from the instances into the join geometry nodes, which plugs into the output. Okay, so let's connect these two. Okay, let's put it like this. Okay, obviously it's rotated in wrong direction, and also I don't like the length of the connector. I think it's too long, so let's change the coefficient to 1 or maybe 1.5, 1.25. That looks pretty good. That looks pretty good. And actually, what I think we will have to do is divide the strand diameter, or multiply the strand diameter by 0.5 for the x and z axis. So let's add another math node. Okay, let's plug it here. Let's separate the connection and feed it also to the z axis. And let's change it to multiply 0.5. Okay, that looks good. And also we have to change actually the length, because now the proportions are out of scale. So let's change it to 0.75 or maybe to 1. Yeah, that looks good. Okay, so let's actually solve the rotation. We have to rotate it by 90 degrees, not on the, I think on the x-axis. Nope. Neither on the x-axis. Nope. On the z one? Yes. So we have rotated it on the z-axis. Okay. Here we are, and let's actually also make the transformation of the connector by half of the length. So let's add another math node. Let's also add and combine XYZ. Let's plug the X. Let's plug the result of the multiplication from this one by 0.5, and let's move it to the translation. Okay, it's not what we want by 1, either by 1. Okay, by 2. We'll change the coefficient until we are at the right spot by 5. Oh, by 6, by 7, because we had the connector 7 meters long, and now we have to use the units to change it like that. Okay, so we have one side finished, and let's go to the other one. Let's copy the instances on points. Okay, let's reconnect the rotation. Let's also reconnect the curves to the source of points. Okay, let's copy the transform. Okay, we will use the same vector for the scale, and just we will add another combine XYZ, and we will multiply the x coordinate by -1. So let's copy multiply, Control-C, Control-V. Okay, we will, I think I disconnected something now. No, didn't I? No, I connected it on a wrong node connection. So let's separate it. We don't want that. And let's connect this one here, multiplied by -1. Okay, let's disconnect also from the scale, because the scale actually goes from here, and let's connect it to the translation. Okay, now it should be okay. Let's see if we plug the instances here and the instances to join geometry, we should actually see, and we don't see anything. Why is that? Why is that? Because the geometry input is not connected to anything. So let's plug it also here. And also we have it on both sides. So let's take the endpoint selection, Control-C, Control-V. let's plug the selection. We have the same side, so let's change the start size to 1 and end size to 0. Okay. Now we have placed the connectors properly. So if we go to the edit mode, we can transform, including the connectors. We can rotate it however we want. Okay. And in the next part, we will address the rotation of the connectors to be properly oriented, always on the upside. So stay tuned.